Hi Lakewood Math 1 students, this is Miss V, and this is the first video in your Linear Equations unit bundle. It's called What is Slope? And before we start taking some guided notes on slope, I'd like to put it in context. We spent some time looking at arithmetic functions that look kind of like this. This one we notice has a common difference of 5. It looks like we're adding 5 each time. Well, arithmetic sequences are very similar to linear functions. We've noticed they graph like lines. And this number 5, the common difference, is the same thing as slope in a linear function. So let's take a look at what is slope. Slope is a constant rate of change between points on a line. And we've used this term rate of change with our arithmetic sequences, haven't we? The slope is a ratio of the rise, which is also known as the change in the y value, delta y. So it's a ratio of the rise to the run, which is the change in x. And we typically use the variable m. Sometimes you'll see the variable a, or the, not variable, but the letter a or the letter m interchangeably. So don't be confused if you see a instead of m. So what we notice about slope is that if we have a line that goes up from left to right, like this line right here, the slope will always be positive. And if we have a line that goes down from left to right, the slope will always be negative. A horizontal line has 0 for a slope, and this guy, our vertical line, which we've already noticed is not a function, has a slope that's undefined. So let's try finding some slopes when we have the graph of a line. I'm going to take a look at this line, and I notice it's going up from left to right, so I'm expecting to find a positive slope when I calculate the slope of this line. And I have a point right here at negative 2. Negative 2, comma, negative 2. And it looks like this point is at 2, 5. And what I notice is the distance between negative 2 and positive 5 is 7. I can just count that. 1, 2, 3, 4, 5, 6, 7. So my delta y is 7 there. And then I'm going to count how much I changed in x value, and that would be, let's go from here. 1, 2, 3, 4. So I went over 4 units. The distance between negative 2 and positive 2 is 4. So my delta x is 4. So I remember that the rise, or 7, goes on the top, and the run, or 4, goes on the bottom. So my slope of this line is 7/4. Sometimes you're going to get a fraction, and in this case it's an improper fraction, and we just leave it like that. Let's take a look at number 2. In number 2, we have a negative slope because the line is going down from left to right. And it looks like I have a point at negative 5, 5, and another point at 4, 2. So the distance in y value from 5 to 2 is negative 3. I went down 1, 2, 3. And the distance here is 5, 6, 7, 8, 9. So it went to the right 9. So my slope is negative 3/9, and I should always reduce that. Negative 1/3 is my slope there. In line number 3, what I'll notice is there is no change in the y value. So we have 0 over, in this point, it looks like They put the point on the axis. It looks like, oh no, this is my line. So my point goes from -5, 0 to -4, 0. So my change in my y value is 0. My change in my x value is 1. So we have 0 over 1, and that's just a slope of 0, right? I kind of went the long way around that. I could have just said my slope is 0 because I know that horizontal lines all have a 0 slope. When I look at number 4 on this page, I notice it's a vertical line and it has a slope that's undefined. And if you'd like to know why this is, it's because this point at 1, 2, and this point at 1, -1, the change in my y value looks like it's -3, but the change in my x value is 0, and that leaves me with a 0 in the denominator, and that's kind of a great big mathematical no-no. So we say that our slope of this line is undefined. In problem number 5, I'm expecting to have a positive slope because my line goes up from left to right. And I have a point right here at 2, 0, and a point at 5, 5. So the change in my y value is from 0 to 5, and that's a positive 5. And the change in the x value goes from 2 to 5, that's 3 units, and I can just count them, 1, 2, 3. And so the slope of this line is 5/3. And again, with this line, I'm expecting to have a slope that's positive because it goes up from left to right. But this line isn't quite as steep as the line in number 5. So when I look at these two lines, I'm expecting this slope to be actually a little flatter. So the change in my y value is 1, 2, and the change in my x value is 2. And so my slope right here is a slope of 1. Notice that slope is smaller than that slope, and we expected this to have a smaller slope because it's kind of a flatter line, right? So what I'd like you to do right now is I'd like you to pause the video, and I'd like you to do the problems on the next page, 7 through 21, for practice. And I'm going to go ahead and put the answers up so that after you've done them, you can check your work and ask any questions that you'd like to. Here are the answers to problems 7 through 12. And if I scoot it up, I think you can see 13 through 18. And the last row, 19 through 21. Okay, guys, that's it. Make sure to do homework for what is slope.